inequalities. In this video presentation, we're going to talk about how we can go through the solving process, but instead of just working with equations, we're going to work with rational inequalities. In this process, you can see we're basically going to have a two-step procedure. The first step, no pun intended, is the most critical step. And that's going to be because we're going to be calculating what we're going to refer to as our critical values. So now the question is, what are our critical values? The critical values will be all of our vertical asymptotes as well as the x-intercepts. Because if you remember, when we solve inequalities, we're actually looking for a solution set. So in this presentation, we're going to talk about how to use a table to help us determine what that solution set is. But we're still going to be envisioning the graph, and in a later presentation, we'll look at how we could use the graph to actually help us come up with a solution set. Once we have these critical values, then as I pre-alluded to, we're going to talk about how to test these values by substituting values in that can check to see if the statement's going to be true for that set of values or if it's going to be false. So let's go ahead and take a look at our first example. In our first example, all right, we're going to keep everything kind of basic here, and we're going to take 4 over 3x plus 7 over x and say that is less than 5/9. So for starters, pause the video presentation this time. See if you can determine what the vertical asymptotes would be and what the x-intercepts would be. I'm going to move forward as if you already had a chance to go ahead and do some calculations here. And what we have is we can see that in our problem, we're going to end up being able to calculate our x-intercept as being 15. And we do that simply by envisioning the inequality as an equation and solving for x. So upon solving for x, we multiply by the LCM, and we get an x-intercept at 15. From there also, not only do we want to get the x-intercepts, we want to get our vertical asymptote. And our vertical asymptotes occur by setting the denominators equal to 0, which in this case is pretty basic because 3x equal to 0 tells us x equals 0 is a vertical asymptote, and then obviously x equals 0 is a vertical asymptote. With a 9, there's nothing that's going to make this a vertical asymptote because that's a constant. We're not changing the value of the denominator also. There's no vertical asymptote there. All right, so now let's get on to this table check. So now what we're going to actually do is we're going to take and make a number line. And on the number line, I'm going to start off by labeling my vertical asymptotes and x-intercepts. And that's where I substituted in the values 0 and 15 from our calculations. Now the next step is I'm going to be testing values. So what I have to do is I have to envision that this number line is set up into 3 different proportions. And I have to see if all values less than this vertical asymptote are true or false. All values between 0 and 15, are they true or false? And all values above 15, are they true and false? Now keep in mind, we're testing to see whether the x-axis will be shaded or not. So since there's no more x-intercepts, we can then assume if we test one value within that range, that all values within that range will be the same or true or the same being false. So if we take a look here at what I did is I started off by substituting in a -1 in for each of the x's. And simply trying to see, is this statement going to be true or false? So that's where I substituted in my -1s. I get a -4/3 minus 7. Without even doing the calculation, I can see a negative number minus another negative number is going to be negative, and the negative will always be less than the positive. So that's going to tell me this is true. So since that is true, I'm going to say this part is true. Or in other words, that's going to be a portion of our solution set. So in my answer, part of my answer is actually going to say -infinity to 0. Now remember, I'm using 0 because that was the vertical asymptote. I'm not using the test value. I'm using the vertical asymptote. Next, I'm going to do basically the same thing, but now I'm going to substitute in a value of 1. So let's just change these to be +1. So this is going to be a +4/3. This would be a +7. I have a +7 already, and I'm going to add a bigger number to it. So therefore, 7 is not less than 5/9. So this is then going to be a false statement. So now I know that inside here, this is false. So I'm not going to have any solutions between 0 and 15. And then finally, I'm going to go ahead and I'm going to substitute in a 16 into here. And again, where does the 16 come from? Well, I just picked the number that's the next biggest number than 15. So if I substitute this in, now all my red numbers here become, this is going to be a positive 16. Oops. Just erase that there. This would be 3 times 16, and this would be a 16 here. So now let's see. If I'm using a 16, this is going to be 4, and 16 reduced, give me a 4, so this is going to be a 1/12 plus 7 sixteenths. Not as clear cut in this case, because now what I see is that I have a fraction and it's equal to another fraction. So let's see here. Let's go a little bit further. And so now I have to be able to add these two fractions. So this is good because now I got to think about, all right, what is the LCM of 12 and 16? So that's going to tell me I have 2 times 2 times 3, and this is 2 times 2 times 2 times 2. So that's going to give me basically 16 times 3, which is 48. So now what that's going to give us is if I go down through here, in order to add these together, that's going to give me, multiply this by 4 over 4, 4 over 48. This one by 3, that's going to be 21 over 48. So now, if I'm looking here at this, I see 4 plus 21 ends up being 25 over 48. Now, 25 over 48, what that is telling me is that is actually going to be a number that's less than 5/9. I can continue working this out to prove that, but I also see that half of 48 is 24, so I'm 1 more than half. And since the denominator is so big, that's going to be less than being 1 more than half, which is 5 over 9. So again, this is actually going to be a true statement. So there, this is going to give me the capability of stating this is actually true, which gives me the final piece of our solution set going from 15 to infinity. So again, in this case, what we end up having is we have a solution set that goes from negative infinity to 0 in union with 15 to infinity. Keep in mind, we're not using the test values. We're using our vertical asymptotes and our x-intercepts as our boundaries in our solution set.